Okay, so yeah, we're unfortunately doing 1.2 again. It feels like I was getting a little tired and forgot to do some of the very crucial questions that I was really hoping to do. Also, 26, my explanation was incomplete. I think I must have just got complacent or something. So I'm just gonna make sure I go through all those questions better so that we can tie this knot much firmer. But anyways, so we didn't do 24, and I really wanted to do 24, so let's do that. Your solution should show you 23 already. 23 already. So I'm just gonna do 24, and hopefully there will be no surprises, right? So those are right there. A, B, C, D. Yeah, this has become a determinant matrix over again. But anywho, so 24. So let's look at A, right? So I already wrote down the answers just to make sure that I'm not doing anything stupid. But anyways, so this is unique and consistent as unique. Now, how do we know that, right? So there are some explanations on the solution manual as well. But how I think is this. So for example, there's three unknowns, right? X, Y, Z, for example, right? Now, Z is defined. Z equals to 1. So that's already defined. Now, using Z, this is unknown, like it could be any number, but it doesn't really matter whether it's 5 or 4, whatever, because we already know the Z value. So 1 times whatever number they want to throw at us will be the whatever number that was thrown. So if this was 5, then it's going to be 5. If it's going to be 1 billion, it's going to be 1 billion, right? So because we can define Z, right, and this is a number that we'll get, we can define Y, right? Which is just one Y, right? So Z is defined, the outcome number will be defined, so the only missing variable is Y, which happens to be only 1, so we can make it work. Now that we know Y, Z, we can do the same thing with this. This looks like a lot of random possibilities, but we know Z, we know Y, and we're going to be given the number, so the only missing variable is the X. And then if we did plenty of questions like this already, but then we can isolate X equals to whatever, and we can define it because Y and Z, these are already defined, right, from previous equations. So we know X, we know Y, we know Z. Therefore, it's unique and consistent. So that's how I would explain things. Anywho, so that's A, right? I mean, I think Carlos also said if how did he explain it again? One sec. Oh yes, yeah. So basically, he's like, I don't know. If you're not great at explaining what I just said, some of the key phrases that you could use is it's in row at echelon form, and every row has leading coefficients, so the solution is consistent and unique. So think of it that way, if you will. That's a more concise way of saying it, right? So make sure it's in raw echelon form, and every row, so all the rows have their own leading coefficient. That doesn't violate any rules that we were talking about. So think of it that way, but common sense is better. That way I don't have to memorize anything, right? See, I had to look it up. I don't want to do that during a test. So anyways, that's A. B. So B was this matrix. I think you guys can see. And then it says consistent, and it has a unique solution. Why is that? Okay, so it looks weird because, wait a minute, we had Z defined, so I can see how we do reverse engineering. But this one, we don't have Z. Z could be anything because we have two random things, right? Now, it's the same thing actually, but we just merely flipped it. So think of it this way. 1, 0, 0, unknown, right? So 1 is X, right? So X equals to this number. X is defined. Some number, Y, 0, some number, right? So what are the unknowns? Z, we don't care because Z is 0, right? This is some number, right? And this is Y, which we don't know, right? So that's the problem. But we know Z because we defined it before. So we know Z, we know the number that's going to come out. Only thing missing is Y. Therefore, we can isolate for Y and calculate Y. Now we know y that's defined, we know x that is defined, they're going to give some kind of number, therefore we can just isolate for z and define it, right? Therefore, this is consistent and it has unique solution. So that's how I would explain things, right? But not everything is going to be like that. You see in 23 too, but more evidently here. So let's look at 24c. Here, classic, if you see something like this, then you know something's up, right? So 1 missing, 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 so it doesn't really help. X is could be anything. So let's see if we can define y and z. We really can't do much, but see here, if there's 1, 0, 0, 0, and 1, 0, 0, 1, so let's say I cancel them, right? Say I did something like line 1 minus plus line 2 will give me the new line 2. So if that's the case, what's going to happen is this will become 0, blah, 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 and 0 minus negative 1 is still 0, plus 2 is 1, right? See this thing? That is inconsistency. Right? 0 equals 1. Can't happen. So that's why this is inconsistent. Let's look at letter D. So this one, I said, is consistent, but it's infinite. How do we know? Well, quite obviously, these two, even without looking. 1, 0, 0, 1, 1, 0, 0, 0, 1. They cancel out, right? So let's say I did, I can write at the bottom, right? Yeah, so let's say L2 minus plus L3 equals new L3, right? Then this is going to be 0, 0, 0, and that's going to be 0. Yeah. 0 equals 0. Therefore, it's an infinite solution. Now, if there's inconsistent row, then, no, not inconsistent row. I keep saying that. Row with inconsistent solution, then, you know, that trumps this, right? But the problem is there isn't any, right? This just says x equals to something defined. So x is defined. Here, x is defined, but there's a y and z that could be anything, right? Now let's say this happened. Let's say. Okay. So let's say the top was, I'm gonna erase this, 1,000 and 0, for example, right? Let's say that was a top, right? So I'm just gonna actually do this, because it could be any number, right? Do you see the problem? Do you see the problem for this? So let's say I did, so line 1 negative plus line 2 equals line 2, right? So if that's the case, that's going to be 0. Uh-oh. Inconsistency, right? So earlier we said it's infinite solution, which is possible, but if you have this, it could be inconsistent. So the answer for this question is actually not consistent and has infinite solutions, or inconsistent. It could be both. It all depends where you plug it in, right? And so because of that, we say it is, so inconclusive, right? Because it could be anything, right? So, so try to find out these things. Just because you found one solution doesn't mean stop. Look for other solutions as well. Let's look at this one. It says inconsistent, like we said, right? So that seems to triumph everything, right? But let's see. Oh, so let's try to see if there's any way to use the third row to do something so that we can create multiple possibilities. Can we do that? Well, for this case, we really can't anyway, simply because in this case, you only get inconsistency if you have very specific first row, right? Here, it doesn't matter what the row is. I am still going to get inconsistency by playing around with line 1 and line 2. So because of that, this may make this, so this doesn't really change the fact that this is going to be always inconsistent. Yeah. So that's why this will be always inconsistent, regardless of these options, because these options are never going to change this. Whereas here, that unknown option, so it was originally like this, right? So that unknown options could cause this to cancel out so that you have inconsistency. But let's say it had, let's say, I don't know, 0, 0, 1, for example, right? Then it will just create another, so it will cancel out so that it's going to be just another 0, 0. Well, 2, 0 equals zeros. You have definable x, right? So that just means, well, it depends. Oh, not it depends. It's always going to be infinite, right? So that's the difference, right? If you have some anything could happen kind of a row, but that can't affect the outcome of inconsistency, then this is always going to be inconsistent. Whereas this one, it depends, right? So hopefully you follow that, and hopefully you can catch those patterns. Yeah, so those are my answers for 24. Practice 23 too. If you're not sure, this is more of a practice thing. Anyways, we are gonna turn slowly. I can move more, and I'm gonna raise it up a little bit. There we go. Okay, so this is my answer for 25. It's odd, so you should be able to see in solution, but just wanted to show you how I calculate these things. So we're gonna start with 25. That's the question, and it's a matter of just reducing as much as we can, and I don't really have to. We did planar elimination question to figure out how we got here, and check the solutions too for what I actually did. But what's important is here, because the unique thing about question 25 and 26 is that instead of having a number, we have some kind of algebraic equation instead of a typical number. So that makes it a little bit more confusing, but again, it's the same concept. So, let's just assume that you got all the way up there. Basically, and check the solution if you're not sure. For 26, I made sure that I show the steps, so which you'll find out. But nonetheless, so you're gonna eventually, after you reduce it as much as I did at the very least, you're gonna left with 0, 0, a squared minus 14 plus 12, not minus 14. I didn't really bother to reduce, to simplify it till the very end. And then there's gonna be a plus 2 minus 16 plus 10. Now, these two are going to be a critical factor, because this has a distinctive leading coefficient, and so is this one. So this one is going to be determine whether you're going to have infinite solutions or no solutions or unique solutions. Okay, so what I actually did was that I got that a square one up here, and then on the right side, which is supposed to be just what equals to, right? That's numbers, a plus 2. I made both of them equal, right? And so I reduced that to a squared minus 16 equals to a minus 4. Okay, so up to here, it's pretty big. Now, if you really want to put z, you can. It might help us, make it easier for you, and I'll show you why. But I didn't do that at the moment. So why is this important? Well, this will decide what kind of solutions we're going to have. Let's say we wanted an infinite solution. Then both have to be 0, right? 0 equals 0. Gotta have that, right? So this is was what I did. There we go. Okay. So if it's infinite solution, 0 equals 0, right? So a squared minus 16 equals to a minus 4. So both sides has to be 0 somehow, right? So I decided, okay, a squared minus 16. What a do I need so that this side becomes 0, and what a do I need here so that this becomes 0, right? So I calculate individually. Let's start with the left side first. A squared minus 16 equals 0. So do the algebra, and then it becomes a squared equals to 16. So therefore, A equals plus or minus 4. Very important, right? It could be either one of those, because you could do negative 4 times negative 4, and it will still give you 16. Positive 4 times positive 4 will also give you 16. So two possibilities. Now, okay, so this could be 4 or negative 4. Gotcha. Let's look at the right side. A minus 4. How could that ever become 0? Simple. When A is 4, right? 4 minus 4 is 0. So, interesting, right? So, so what happens is on the left side, you can have plus 4 or negative 4 to get 0. On the right side, it has to be only 4. So in order for it to be 0 equals 0, A has to be 4, right? Which makes sense, right? Because if you put 4 here, it will be 0. If you put 4 here, it will be 0, right? But that discrepancy is a hint as to what it's going to be inconsistent. Why? Because, let's say, remember, for this one, a squared minus 16, the possibilities were plus 4 or negative 4, right? Let's say we chose negative 4. If you choose negative 4 here, really doesn't matter because it's going to be squared. So 16 minus 16, 0. Perfect. Here, though, look at it. A minus 4, right? So if A is negative 4 minus negative 4 will give you negative 8. 0, negative 8. Classic inconsistency situations, right? So if you choose negative 4 as an A, then it's going to cause inconsistency. Whereas 4 will give you infinite solutions. Now, what about unique solutions? Quite honestly, anything but 4 will give you all the unique solutions that you would ever want. Which makes sense, right? Because if it's not 0 equals to 0, or 0 equals to 1, or 2, or whatever, some number, right? Which is the inconsistency, right? So if it's not this, and if it's not this, what's the only alternative left? Unique solutions, which are consistent, right? So I would just write it that way, right? Okay, so that's that. That's 25, pretty simple. 26 is this baby, right here. Okay, right, so we started off here, right? So so it's gonna look a little bit different because our prof wrote the used a little whatever. See, I'm rambling again. But yeah, so basically the question might look a little different from the notes, like I've been saying in the original video. But nonetheless, this is a fixed form. So so this is what I did. This is what I did. Hopefully you guys can read it. Anyways, I don't need to read this. You guys already should be pretty familiar with this by now. What we care about is this last row, right? Just like before, like 25, there's going to be two algebras, and those are going to determine whether the solution is going to be unique or consistent, or it's going to be just inconsistent altogether, right? So I'm going to do the same tactic that I used before, right? So on the left side is negative, open bracket, a squared minus 3, close bracket, negative 1 equals to a minus 2. So once I simplify, it's going to be just negative a squared plus 2 equals to a minus 2. Okay, oh, and we're almost getting cut off. So, there we go. Okay. Seems to move, but anyway. So, let's talk about infinite solutions first. So, like I said, like we did before, right? We want to make sure the left side is 0 and right side is 0, right? So, negative a squared plus 2 has to equal to 0. Let's make that happen somehow, right? So, this is what I did. So, simple algebra, right? Move the 2 to the other side, and then remove the sign. Then you have a squared equals to 2, square root both sides. Then a is going to be plus or minus square root of 2, right? Okay, that's great. What about the right side? A minus 2. So what does a have to be in order to be 0? The only option is 2. So can it ever be 0 equals 0? No, because if I make one side 0, this will not be 0. If I make this side 0, this will not be 0. What do I mean by that? So let's say a minus 2 is 0, so a has to be 2. There's no other options, right? Now, use that very same 2 and plug it into the left side, which is going to be 2 to the power of 2 is 4 minus 4, right? So the negative, right? Negative 4 plus 2 is going to be negative 2. Negative 2 equals to 0? No, that that's not infinite solutions, right? So it's not going to happen. Let's see, yeah, and yeah, so that's that. What about any inconsistency? Well, inconsistency just has to be, we just have to make sure so that, let's see here, sorta. Okay, so inconsistency. So basically what I did was the left side, right? The minus a squared plus 2, that can't be 0, right? No, that can't be 0. It has to be 0, actually. But on the right side, it has to be some number, right? Because if it's 0, then, you know, and then it's going to be 0 equals 0, so that's going to be infinite anyway. So 0z has to somehow equal to a non-zero number, right? That's all there is. So I'm going to try to figure out what negative a squared plus 2 will make it 0, and we already calculated that's plus or minus plus or minus square root of 2, right? So that's now on the right side. How do I make sure it's not 0? So remember on the right side, a minus 2, the only way that side could be 0 is if a equals to 2, right? So anything else, it will give you some kind of number. It could be a negative number, positive numbers, ugly number, nice number, it doesn't matter, right? So because the left side gives you 0, if we use a equals to plus or minus square root of 2, then, you know, let's plug it in that, right? So, you know, it's probably going to be a really ugly number, but let's say square root 2 minus 2 is going to give you some number. Negative square root of 2 minus 2 will give you some kind of a number, right? Not a nice number, but it will give you some kind of number, right? So on the left side, if you use this a value, it will be 0, but on the right side, it will give you some number. If that's the case, by default, that is inconsistency, right? Because it's 0 equals to some number. Then, you know, that's what happens. So because of that, it is inconsistent if a equals to plus or minus square root 2, as shown here, right? So that's easy inconsistent, right? Can there be a unique solution? So like I said, get the infinite solution possibilities out of the way, inconsistent possibilities out of the way, then anything else is by default unique solution. So inconsistent is plus or minus square root of 2. Infinite solution does not exist, as we said. So anything except plus or minus square root of 2, unique solutions. Always, always, always. So that's all there is. Now your teacher, Maria, who happens to be my prop. She's this sort or something like this, but she just did a little bit differently. Maybe this is what you prefer. I can see why some people like this more. So we both reached this conclusion, even though somehow, right? So if that was the case, then, you know, she just said, well, technically there's z here, right? Because it's a 0, 0, and there's a z there, right? So that's that. So I'm going to isolate for z. So that's going to be a minus 2 divided by negative a squared plus 2. Okay? And, you know, and that's, so that's going to be your z value, right? So once you establish that, then we say, well, can z, oh, no, actually, no, that won't tell you if it's consistent or inconsistent or anything like that. That just gives you a generic z value. Obviously, there are some numbers you can look and say, oh, wait, something is going to be wrong, right? For example, you can't divide anything by 0. So negative a squared plus 2 cannot be 0. Interesting. When did we use that concept for other things that we've been solving, right? A squared equals 2 square root is going to be a plus or minus square root 2. We talked about that, right? So this happens when this equals to 0, correct? That's why we were able to move around. So interestingly, if the bar, you cannot divide by 0, and that by default is inconsistent. Just like what we've been talking about here. Different approach. I like this one better because this is a little bit more clear, but ultimately they give you the same thing. So that's the idea. Consistency, the top has to be 0, No. Yeah. Oh, that's one thing that I could have made a mistake, and some people might as well. If you look at here, it says, well, it's 0 equals 0, right? So, a minus 2. What if I make a minus 2 equal to 0? Then you have 0 on the right side, and, if you have 0 on the left side, that works too, right? Because 0 equals 0, right? Well, here's a problem though, right? Because it could be anything. Because z and a are not related to each other. So, in order for right to be 0, yes, you're right, a has to equal to 2. So that it becomes 0, right? But that's not a guarantee that z is going to be 0, right? Z could be any number. And then right now we're trying to figure out what condition for a, right? So, because z is not related to the a at all. So, yeah, so that's why there's going to be a guaranteed infinite solution. So that was my argument, right? So, yeah. And I haven't quite actually finished all the way, because this is really the most important part. What you also have to do is, once you use this method to find out the z, right? Then you use this z to figure out what y is, and then use that y to figure out what the x is. And that can be very doable because, wait, can you see this part? Yeah, we can, right? So, once we have defined z, look at here, -6, 1, -3, right? 1, z, right? But z is defined by this. So, that's going to be 1 times z, this really annoying solution. Actually, let me just write it down so that so some people know exactly what I'm talking about. 6y plus, oh god, a minus 2 divided by -2 squared plus 2 equals to -3. So, I mean, you can find it, maybe not exact solution, but you can find it, right? So that's going to be, y equals to -a squared minus, okay, that is not pretty. So that's going to be minus 3 divided by -6. So, well, at least the negative cancels out, but I'm not sure if that's really helpful, right? So you can define y. That's the whole point, though, right? You can define y, and you know z, you know y. So the first row that has x, y, z, and the number, we know the y and we know the z, and we know the number that comes out of it. So we can isolate for x and find out the x identity as well, right? So that we can do, right? As a matter of fact, I think oh, yes. Oh, 26, okay. Yeah, so as a matter of fact, that's exactly what Maria did as well. Except she didn't really, well, okay, maybe I have a poor note-taking skills, but I don't think she even did this. I think she just left it as y's and z's to find out x, right? But nonetheless, that's what you would do, right? So it's not, the hardest part about 25 and 26, this is a 26 of course, is, trying to figure out these conditions, right? But defining z and finding y and x is fairly easy. This is what we've been doing in earlier questions, right? So, anyways, just wanted to also mention this as well, same thing. So, because I haven't technically quite finished answering the question, I don't think. So, we already discussed about infinite solutions, inconsistent, and unique solutions, right? So now we just want to figure out, let's define z, y, and x, which should be doable because z is defined, right? So it's going to be, so again, so that's why I put z here, remember? So if we use Maria's tactic, then, isolate for z. Z equals 2, so see this equation and follow along. A minus 4 divided by a squared minus 16. The only restriction for that is maybe you could write down, what was that? So it's a squared 16, so a is going to be plus or minus 4, right? So z is going to be this, except a cannot be plus or minus 4. That's all you have to write down, right? So once we define z, we can find out what y is. Well, how do we know that? Well, because Can you see? Yes, we can. Yeah. So up here, second row is negative 4y plus 14z equals negative 10. Okay, for sanity's sake, let's oh no, we can't reduce it. I thought we could. 7 and 14, right? But there's so okay. So technically, it's kind of look horrifying, but we can do it. So it's going to be negative 7y equals to negative 10 minus 14z, which is going to be negative 10 minus 14z. That was a minus 4 divided by a squared minus 16. We have that, right? And then divide the whole bloody thing. Oh, okay. Really should try not to swear. My apologies. Negative 7. That. And you may not be able to see totally, but that will be y. So you see the pattern, right? I could keep going, but it's sort of, you know, it's not very useful, right? But once we know the definable y and once we know the definable z, then really we can find out the x as well, right? So using the same pattern. So you know, I wouldn't really worry too much about this algebra, and I highly doubt that your teacher will force you to spend time trying to simplify these equations. So I would be more just worried about, you know, playing around with the the algebra's equations on the last row to figure out whether it's infinite solutions, inconsistent solution, or unique solution. That is, I think, the half the battle, and rest of this is, well, you know, since you learned how to solve this in the earlier questions, maybe we can just ask you again, just to, you know, make sure you really know what you're doing, right? But we're not doing anything new here, right? So anyways, yeah, I just wanted to make this video of that, so and hopefully this would address some of the confusions and angers if you were watching the part B, okay? So my video editing skill is not sufficient enough for me to get these films and then insert it into part B. If I could, that would be awesome, but maybe I will do that over the summer. But again, the point is just the biggest priority is to get all this stuff out there so that you guys can see it at least, right? So that was the idea. So hopefully this clears up a few things, and 1.3 will be a little bit delayed. That's not fine. But anyways, yeah. So I will start making videotapes for 1.3, 1.4. Hopefully I can get all this done by the end of Friday. I was hoping to get this all done by the Friday morning, as I sort of mentioned on the email, but this may or may not happen. But at least you have 1.2 now, so that will keep you busy for a while. Or, you know, you guys are just patient waiting for 1.3 and 1.4 because... Anyways, I'm now rambling because I'm getting tired. So, anyways, that's all I have to do for 1.2. There will be no more videos, hopefully, unless you guys point out that I need to make more videos because I made a mistake or whatever. But, you know, I'll worry about that later. So, anyways, thanks for watching so far, and then I will see you again in 1.3. So, I will just write L3 negative equals L3. Okay, so going this way, and then I'm going to do 1, 0, negative 2. Is that too high? It is totally too high. Okay, 1, 0, negative 2, negative 3, 0, 0, 7, 14, 0, 1, 3, 9 is good. So I managed to get to there, and how did I get there? I used L2, L3 plus L2 is a new L2, L3 plus L1 equals to new L1. So that's what I have. Leading coefficient, could do more work there, but okay. So what, now technically speaking, you could be just calculating straight from here, right? So I decided to go simpler, but again, So let's get there first. So the next line I did was 1, 0, negative 2, negative 3, 0, 0, 1, 2, 0, 1, 3, 9. And then basically, the only difference I have here is I wanted to reduce this. So 7 and 14, I can divide both by 7. So whether there was 1 over 7, L2 is the new L2. So once you have that, it becomes simpler. And now I'm going to be using this second row to get rid of all my leading coefficient computations, right? So then that's going to be, actually that's where it gets interesting. So it's going to be 1, 0, 0, 1, 0, 0, 1, 0, 1, 0, 2, 3, because of 2L2 plus L1 equals L1, 3L2 plus L3 equals new L3. Now, quick question again. So it looks really nice. Isn't this reduced echelon form? It is not, because remember, leading coefficient. Okay, good. So next leading coefficient should be on the right. Yes, it is. Next leading coefficient should be on the right. No, it's right here. So if you want to put this into a reduced echelon form, it's gonna be and you could say L2 and L3 are switched. You could do it. Again, I don't know if you have to do this because ultimately we're looking for solution, right? So if they wanted in reduced echelon form, then please put it this way. But if you do that, it's so simple, right? So it's going to be like x, y, z. I'm putting in this format so that you're also familiar with this, right? I'm saying x equals to 1, y equals to 3, z equals to 2. To be careful, yeah, 3, 2. You don't have to write this way. You could just say x equals 2. Oh yeah, no, you can see, yeah. So then it's going to be, you could just say x equals to 1, y equals to 3, z equals to 2. You could write that. Again, it really doesn't matter. Oh, but no. Okay, sorry. So this is the step you would go through. Sorry, I didn't read the question carefully enough. If you look at 35, although this is correct, this is not x, y, and z. If you read the question carefully, this is x squared, y squared, and z squared, right? So because that's how I set it up, right? When you look at the matrices, it's like x squared plus y squared plus z squared. So it's actually those, right? So in order to figure out the actual x, so my apologies. Well, no, we could use this, right? Square, 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 square. So because of that, we can say x equals to 1 because square root of 1 is 1. Y is square root of 3. Z is the square root of 2. Now, be careful though. Technically speaking, it should be both plus and minus. Right? Because minus 3 times minus 3 could give you a 3. And vice versa with 2. So, this will be the real answer. There you go. Okay, and the long-awaited one, the question that seems to, it's not a really big deal, but a little different from everywhere else. The last question at long bloody last, 36. So again, same idea. So when you draw the matrix, it's the same thing. The only weird thing though, so if you do this, it's like, yeah, I know how to do it already, right? The only difference is this, instead of x or x squared, it's going to be 1 over x, 1 over y, 1 over z. Right? So, but again, it really shouldn't matter, right? So, if it really confuses you, I would just write this as a big X, big Y, big Z, and just say like, you know, let X is equal to 1X. Big Y equals to 1 over Y. Big Z equals to 1 over Z. Right? Make sure these three are small capital, right? To show the difference, right? So that's all I would do, and just pretend that this is the same thing as what we were doing before. So then the solution becomes pretty trivial, right? So then, oh, wait, you can't see. So yeah, so what I meant to say was, so let's, instead like it's originally this, right? So what I meant to say was get rid of that. So to say big X equals to 1 over X, and then big Y is supposed to become 1 over Y, Z becomes 1 over Z, right? So put it that way, so then once we figure out what X and Y, Z is, we can go back by just inversing it, right? So let's say X turned out to be 5, then my real X, small x is 1 over 5. That's sort of an idea. So anyways, let's start simplifying this. And we can go, yeah, so 2, -4, 1, 0, -1, 0, -1, 0, 11, 6, 6. L1 plus L3 equals L3. -2 L1 plus L2 equals L2. So again, the reason why I did that is because I'm happy with line 1, right? Leading coefficient. Competitors, got to get rid of them. You can do that with using this. And the rest is just doing the same steps as we've been doing before. So, don't want to get too repetitive. Next one, I just didn't like this. I really like this because it's the second rule because it's already simplified as much as possible. But don't like the negative sign. I don't know, that's just me. Not the end of the world, but I just choose to convert it in case if I need line 2 to subtract something and I like simple positive number. So L2 negative equals 2 new L2. Okay, I'm going to be writing on my side now. Okay, and then what I'm going to now do is, again, if you look at this guy, I like this leading coefficient very much. So, got to get rid of 2 and 11. So, line 2 stays the same. 1, 0, 1. Okay, and then, oh, okay, maybe that will help. And then that's going to be, so what I'm going to now be doing is negative 2L2 plus L1 equals to new L1. Negative L2 plus L3 equals new L3. And that will give me 0, 0, 6, negative 5, 1, 0, negative 4, negative 1. We are getting close, or maybe already there. Okay, well, now technically you could just, start here because, y equals 1 already. You know this solution, so you can just find it on your own. But, yeah, I don't know. I just felt like I should keep simplifying. I have to simplify in a linear equation or, in a linear equation or in a matrix anyway. So I just decided to do it here. Again, up to you. So I just wanted this to be simplified. So what I did was just divide both by 6. So that's going to be 1. It's going to be 5 over 6. And that's going to be L3, 1 over 6 is the new L3. Every time I say this is the new something, never mind, no, I'm going crazy. You know what I'm saying. Okay, so that's that. And then once we have this, I can use this and this to get rid of the negative 4, just so that I don't have to bother with the linear, convert to linear algebra and do algebraic calculations, right? I know it sounds weird because I'm technically doing that here, but bear with me. So 0, 1, 0, 1, 0, 0, 1, negative 5 over 6. I'm happy with those. I want to get rid of the negative 4 because it's competing with my leading coefficient here. So get rid of that times 4. 4, L3, oh crap. Can you guys see? Yeah, we can totally see. 4 times L3 plus L1 equals to L1. So if that's the case, that becomes 13 over 3. Oh, yeah, how did I get 13 over 3? Because L3, so that's 4, negative 20 over 6, and then it used to be negative 1, so that's going to be negative 6 over 6, so that becomes, yeah, oh yeah, that becomes negative 26 over 6. That's the same thing as 13 over 3. Hence it's right there. By the way, 13 over 3 is negative. Anywho, that's that. Okay, so now that we've established that, so from here we can say big X equals to negative 13 over 3, big Y equals to 1, big Z equals to negative 5 over 6. However, we are not looking for big X, big Y, big Z. We're actually looking for the little z. Remember these things? Oh, no, you can't see that, can you? Yeah. So remember, x equals to 1 over x, and y equals to 1 over y, and so on, right? So I'm going to inverse it. So, all right, here. So if that's the case, then x, which equals to 1 over x, hence x is 3 over 13 minus, right? Because you've inversed it. So you inverse the same. Y doesn't really matter that much. Y equals 1 over y. So y equals 2, 1. I should make this a little bit more clear. Big Y equals 1 equals that. No. So anyways, z, same thing. So 1 over z, which equals 2, negative 6 over 5. Just flip that upside down. So these will be your answer. Alright, so finally we are done. 1.2. I will start posting 1.3 and 1.4 as soon as possible, once I figure out the compression. Yeah, that allows to upload videos a lot faster. So, but hopefully 1.2, all the things I've done in 1.2, to the point where I'm actually losing my voice. Hopefully this has helped a lot, and this will give you enough practice and the confidence so that 1.3 and 1.4 will be a smooth sail, because we should be expert in elimination, like addicts, Minesweeper addicts, right? So we will get into 1.3 as soon as my voice is back to normal. Yeah, so that's all there is. Yeah, so yeah, exactly, yeah. So yeah, anyways, hopefully this was useful to you, and we will see each other again for section 1.3 soon.